Question 11 is quite a tasty question, which essentially is about the laws of logarithms, but it's actually complicated by the fact that we're told here that p is equal to log to the base q of 2, and we're asked to express our answers in terms of p. So how on earth do you go about answering this? Well, essentially, very much like the previous question, it is all about the base that you use here. So if you take this first expression, log to the base q of 16, we're ultimately trying to end up with something which can be expressed in terms of log to the base q of 2. So is there any connection between base 2 and 16? Well, yes, there is. We can express this as log to the base q of 2 to the power 4, obviously given that 16 is the same as 2 to the power 4. And then here we can just use the log law that log x to the y is the same as y log to the x to rearrange this, so we can bring the power down and say that that is the same as log to the base q of 2. We've been told already that log to the base q of 2 equals p, so this is just going to be 4 times p. So the first part A, is going to give us an answer of 4p. For the second part, again, at its heart, it's just a question of log laws. So in essence here, you've got log to the base q of 8 times q, and we should recognise that if we have log AB, we could express that as log A plus log B. So in this instance, I can express this as log to the base q of 8 plus log to the base q of q. Now, again, we're going to have to somehow convert this into a log to base q of 2, and again, we can use the previous log law we used here and express this as log to the base q 2 to the power 3, because obviously 2 cubed is equal to 8. Again, bring the power down, so we can now express this as 3 log to the base q of 2 plus log to the base q of q. This, we have already established, is equal to p, so this is going to be the same as 3p plus whatever this is here. Now, we should recognise that if I was to write this here, log to the base q equals some value which we'll call r. And again, using this or expressing this in exponential form, we would say that q to the power r equals q, and therefore establish that r must be equal to 1. And indeed, we can generalize this, and we can say that log to the base a of a will equal 1 for any number. So this equals to 1, so the solution will be 3p plus 1.